So these are the rules that we went over on Thursday in regard to drawing Lewis structures for covalent compounds. So you are going to count the total number of valence electrons. If it is an ion, and that's one of the things we will add today, you are going to add or subtract electrons for the charge. So everyone should have a copy of these rules somewhere. You will not have them during the quiz on Friday. There's a quiz on this on Friday, which I felt gave everybody enough time to get caught up on it, okay? Then we draw the skeleton structure, which is basically you just put the atoms, like you put the central atom in the middle and you stick the other atoms to it around it. So that's drawing the skeleton structure. Draw lone pairs around all the atoms that need them. That means that everybody needs to have how many electrons? Tell your partner, how many electrons does everybody need? How many? 8, except for hydrogen, which only needs 2. Now, there's a couple other exceptions, and those are ones we're going to cover today, and those are beryllium, boron, and aluminum, which I like to refer to as B-ball. This is kind of like basketball, yes? B-ball. And we'll talk about those ones today. Once you have your structure and all your lone pairs, you count and check. So you count up all the electrons in your structure and you check to see if it's the same as the number of valence electrons you had at the beginning. Every line counts for 2 electrons. So a line is 2 electrons. 2 dots is 2 electrons. A single dot is 1 electron. What's the only issue I have with single dots? With very, 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 very few exceptions, there should be no unpaired electrons in the Lewis structure of a compound or molecule, okay? Of any, no unpaired electrons in Lewis structure of a molecule or ion. You can have unpaired electrons in an atom, but you will not have unpaired electrons in a molecule or an ion. So you should really not see single dots. You should always be counting 2, 4, 6, 8. Yes? So once you have your entire structure and you have counted the electrons in your structure and you have checked it, you say, do I have the same number as in step 1? If I do, then I can just jump all the way to step 7. And if we go and just check out what is step 7 is just, we check if it's an ion and we put brackets in charge if it's an ion. Okay, so you're pretty much done. If your electrons in your structure match the number of valence electrons, you're really good to go, okay? Now, if you have too many electrons, then your structure, you're gonna have to erase some, okay? And you're going to go to step 5. And step 5 is erasing lone pairs. And you don't just erase them from anywhere, you erase them from the central atom until your numbers of electrons add up. Is it less than the number of electrons in step 1? You're going to count up how many extra pairs you need, and you'll just place them on the central atom. Okay, those don't make a lot of sense until we've had examples with them, so we're just going to leave that at this point. Okay, once you have erased lone pairs, you need to turn lone pairs into bonding pairs to bring the central atom back up to a full octet. This will give you double and triple bonds. Now these rules are very nice, have them out in front of you. We are going to do a few examples because they don't make a lot of sense without examples. Okay, so let us start. Some of you will find this easy because you have already done this last week, so you can try it just on your own while I'm doing it with people who have forgotten or never knew it to start with. What if I were to give you, let's see, CH3I. What is step one? Tell your partner, what is step one? Count what? Valence electrons. So eventually you'll probably just be like, okay, I'm going to do number one, I'm going to do valence electrons. There's a couple ways of adding them up. Is there anyone who would like to know how you can tell how many valence electrons there are in an atom? How do you know? Tell your partner, how do you know how many valence electrons are in an atom? How do you know? The group number, right? Group number. Group 1 equals 1. Group 2 equals 2. And then group 3, 13 equals 3. 14 equals 4, etc., etc., etc. Okay? So that's how you know how many valence electrons. So let's take a look here. We have carbon. How many valence electrons does carbon have? Make sure you have your periodic table out in front of you. It has 4, yes. Now for hydrogen, we have to take into account the fact that we have this 3 down at the bottom. So we're going to say plus 3 times, how many valence electrons does hydrogen have? It has 1 valence electron, okay? So there we go, so that's gonna be our hydrogen, and then we have iodine. How many valence electrons in iodine? Tell your partner. 7, okay. So we now have 4 plus 3 plus 7 equals how many? 14 valence electrons. You get 1 mark for showing this, so show it, okay? 1 mark. Step 2. Tell your partner, what is step 2? Step 2 is the skeleton structure. And the key idea behind the skeleton structure is to figure out who is the central atom. Tell your partner, how do you know who is the central atom? How do we know who's the central atom? It is usually written first. Okay, and it is usually the singleton atom. What do I mean by a singleton atom? Tell your partner. Who are the singleton atoms in CH3I? The C and the I, because there's only one of them. So the singleton atoms means there's only one in the molecule. Okay, so that's going to be the C and the I. But we're going to go with the one that is written first. You can also use, these are just some guidelines, but you can also use your brain, right? And you can say carbon has 1, 2, 3, 4 unpaired electrons. Hydrogen has 1 unpaired electron, and iodine has 1 unpaired electron. So most likely, how many bonds will carbon form? 4 bonds. How many bonds will hydrogen form? 1 bond. So can hydrogen go in the middle? Okay, and iodine? 1 bond. So probably not central. Certainly not if carbon is around. If carbon is around, put it in the middle. Carbon, 4 bonds, always in the middle, okay? Okay, so we're going to put carbon in the middle. Remember, we have CH3I. Carbon goes in the middle. We will put things at the top, at the bottom, on the side, and on the side. Top, bottom, side, side. And we have 3 hydrogens. Does it matter where you place them? No. H, 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 I. So that is our skeleton structure. Put the central atom in the middle and attach everybody to it with bonds. How many electrons have we used so far? Tell your partner. Tell your partner. I'm not hearing a lot of people. I'm hearing 2 people in front of me. How many electrons is a line? 2. So we have 2, 4, 6, 8. We've only used 8 electrons so far, so we're doing well. Now, our step number 3, tell your partner what step number 3 is. If you have to read it, that's fine. What am I adding? I'm adding lone pairs. What's a lone pair? Describe to your partner what a lone pair is. Lone pairs are pairs that are not involved in bonding. They belong to one atom only. By the way, if there's anyone who wants these notes at the end of class, you can ask for a copy of them, okay? All right. So we're going to take our structure, and I will redraw it here. Normally I would just do this all in one place. I wouldn't be redrawing the structure every time, but we have a C, we have H, 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 and I, and we are adding electrons to anyone who does not yet have an octet. Oh, that rhymes. It does not yet have an octet. Huh, okay. Who does not have an octet that needs one? Tell your partner. Out of all of these atoms, who needs an octet? When I say who still needs an octet, that means who does not have one yet that needs one. Does hydrogen need an octet? No, because it only needs two. Because it's only that first shell that's getting filled out. How about carbon? Carbon already has an octet, so no, it does not already has 8 electrons. Each bond is 2 electrons. Now, how about iodine? Does it need an octet? Yes, because it has only how many electrons so far? 2 electrons. So how many pairs do we need to add to iodine? We need to add 3 pairs. So we go 1 on the top, 2 on the side, and 3 on the bottom. With Lewis structures, you should always be filling in top, bottom, side, side. Okay, there shouldn't be weird things like sticking out at strange angles unless I tell you so. Okay, there are exceptions where that does happen, but for now, just stick with top, bottom, side, side. So that was step 3. What is step 4? Read it out loud to your partner. We're going to count. What are we counting? Electrons in the Lewis structure, yes? Okay, so let's do that. Remember, you're just going to count 2, 4, 6, 8, 10 because everything should be a pair. A line is a pair. So 2, 4, 6, 8, 10, 12, 14. So we're going to count the electrons. And the second part of step 4 is and check. So count and check. What are we checking it against? The original valence electrons. So do we have the same number as our original valence electrons? 14 electrons. Go back to step 1. How many did we have? 14 electrons. We're basically done. The only thing we need to do is we need to check and see if it's an ion. Is it an ion? If it's not an ion, we're just done. Oh, done, done, done. Okay. Not an ion. So we are done. Okay, so that is our Lewis structure right there. All right, and yes, it took me a long time to write all of that down, but you'll just be doing it all in one place. You'll have like, you know, the electrons, and then you'll just like add electrons, and then you'll be like, oh, and here we are. Okay. Let us try something with an ion. Okay. Ions. Let us do NH4 plus. Step number one, tell your partner what step number one is. In fact, why don't we list all the steps? List all the steps for your partner. Step number one is literally say them out loud to your partner. Okay, valence electrons, skeleton structure. What am I adding in step 3? Lone pairs. And what am I doing in step 4? I am counting and checking. Okay, we're going to just go up to step 4 for now, okay? Because we'll worry about the next ones, but those are your first 4 steps. Those will be the same for every single structure, okay? So, valence electrons. We have nitrogen. How many valence electrons does nitrogen have? Group 15 has 5. We have hydrogen, and the hydrogen, we have 4 of them, and each hydrogen has 1, so we're going to add 5 plus 4. Now, here's the tricky bit. When you have an ion, you either add or subtract electrons to compensate for the charge. If you have a +1 charge, does that mean you gained an electron or you lost an electron? That means you lost an electron, therefore you're going to subtract 2 electrons. If you have a -2 charge, that means, did you gain or lose electrons? You gained 2 electrons, therefore you would add 2 electrons. In this case, we have a plus. What does that mean? Plus how much? That means plus, single plus means just +1. And so a +1 charge means -1 electron. Huh? Whoa. That should be a 1. Thank you. Nobody else got that? I think I was already ahead to the next part. My brain was like, oh, we're doing 2 next. Okay, yeah. There aren't any +2 ions, so we will never be like taking away 2 electrons. Okay, so we have 5 electrons from nitrogen, 4 electrons from the hydrogens, and then we take away 1 for the charge. And so we now have 5 plus 4 minus 1 is 8 valence electrons. Skeleton structure. Who goes in the middle? Tell your partner, who goes in the middle? Is it the N or is it one of the H's? The N. Why the N? N is a singleton. N comes first. And also, hydrogen can only ever have how many bonds? 1 bond. So cannot be central. So we're like, oh, nitrogen should be central because it's the singleton. It should be central because it comes first in the compound, and it can't be hydrogen because hydrogen can only ever have 1 bond. So let's draw our structure then, and I can actually fit it in over here. So we have nitrogen, and I need to attach 4 hydrogens, 1, 2, 3, 4, H, 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 H. What are we, we're gonna add, oh no, yes, we're gonna add lone pairs next. Who needs lone pairs in this structure? Tell your partner. How many electrons does N have? 2, 4, 6, 8. Does N need electrons? Nope. Does hydrogen need electrons? Nope. Do we need to add any lone pairs? Nope. So step number 3 we can skip this time. Okay. And now we're going to count and check. What are we counting? The electrons in the structure. Okay. So every time you see a line, you count 2. Every time you see 2 dots, you count 2. So 2, 4, 6, 8. Is that the same as our original number? Yes, it is. We counted and we checked. Now step 5, oh no, step 4, we count and check, and now let's go and see, what does it say if the number equals? What should we do? It says, are there the same number of electrons? Oh, that's good. We're going to go to step 7, which is basically just checking to see if it's an ion. Is it an ion? Yes, it is. If it's an ion, what do you need to include? Brackets and charge. Brackets and charge. What type of brackets? Round brackets or square brackets? Square brackets. Thank you. And does the charge go on the inside or the outside? On the outside. And is that a good structure? Yes, it is. We are done. Woohoo! Okay. We are going to now try. Actually, before we do that, we are going to go quickly to, where is it? Here we are. Hints for Lewis structures. This is on page 7, but it's in your little booklet that you have. Okay, so you can just flip to page 7 there. Okay, because this gives you some good guidelines. Of course, we know that most atoms want a full octet. That means 8 electrons in their valence shell. We also know that hydrogen is an exception to the octet rule, yes? But we have 3 others that are also exceptions to the octet rule, and you are responsible for memorizing them. And we are going to use the mnemonic device B-ball, okay? Which is Be for beryllium, and then B for boron, and then aluminum, Al, okay? And this is only a good question if you're like me and you don't know a whole lot about sports. How many people are on the basketball court at any one time on one team? Less than 8. That's Miss Spence's answer. How many? I don't know, but I know it's less than 8. Okay, it's not really a very good thing, but maybe you can laugh at Miss Spence and that will help you to remember. I hope it does. Otherwise, you can just laugh at me and enjoy that part of the day. Okay, so now how many do these need? And I'm going to say right now it is complicated because beryllium is a metal and yet it bonds covalently. Aluminum is a metal and yet sometimes it bonds covalently. Okay, on your test or quiz, there will be a section that is covalent bonding. There will be a section that is ionic bonding. And if it's in the covalent bond section, you're going to do covalent bonds. If it's in the ionic bond section, you're going to do ionic bonds. It'll say, okay? So, even though these are metals, they can covalent bond. And when they covalent bond, how many electrons does beryllium need in total? Beryllium needs 4 electrons in total, 2 pairs. Okay, now if you look at beryllium, that's 2 unpaired electrons, so that's 2 bonds. So it kind of fits that nicely, okay? But you can just remember beryllium needs 4. Boron and aluminum, they each have 3 electrons, 3 unpaired electrons. Therefore, they're going to have 3 bonds, which gives us a total of, you have 3 bonds, and you only have these, and you don't have a lone pair. That gives you 6 electrons. Yes? Okay. And we're not going to go to any of the other exceptions to the rule. We're just going to go up to here for now. Okay, we'll touch the other one. So you need to know hydrogen, and you need to know who are the other 3. Close your eyes and tell yourself. Who are the other 3? B-ball. And when we say B, it's B-E like B-E-B. To be or not to be. Okay. How many does beryllium need? How many in total? Beryllium needs 4. How many does aluminum need? 6. How many does boron need? 6. Okay. So now we're going to do a couple more examples. Okay. AlF3, covalent bonding. And the reason I'm telling you that is because aluminum is a metal, and so you might think, oh, that's ionic bonding. I'm going to tell you it's covalent bonding. Until you've memorized them, I would advise you write the steps over to the right. So it's valence electrons, skeleton structure, lone pairs, count and check. And we'll go past there soon, but not just yet. How many valence electrons does aluminum have? 3 valence electrons. Fluorine has 7, but there are 3 of them, so it's going to be 3 times 7. Okay. And then we have 3 times 7 is 21, plus 3 is 24 valence electrons. Skeleton structure, who goes in the middle? Aluminum, it is first, and it is a singleton. We are going to put the 3 fluorines around it. Doesn't matter where they go. And now we're going to add lone pairs until all atoms have 8, except the exceptions. Do we have any exceptions here? Yes, we do. We have aluminum needs how many electrons? 6 electrons. How many electrons does aluminum have right now? It has 2, 4, 6 electrons. Already done. Yes? Do the fluorine need electrons? How many electrons should fluorine have? Fluorine needs 8 electrons. How many does each fluorine have at this point? Right now it only has 2 for that bond. So how many pairs has 2 electrons? How many lone pairs? Add 3 lone pairs. And don't put any on aluminum because aluminum is an exception. Yes. Yep. Step number 4, count and check. I'll do it in blue maybe because I've already done some yellow. I have 2. Oh, come back. There we go. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. 24, 24, yeah! So we're done, unless it's an ion. Is it an ion? No, so we're done. Is good? Okay, so at this point, you guys should be able to do, let's see, groups A, B, and C on page 124. Okay, so you did question 1, 2, and 14 already. So let's have you do questions 2, 3, 7, 8, 9. Oh, hang on. No, A, B, and D. No, just A and B. You can only do A and B? Oh, no, you can do group E. Oh, and E. E. 26, 27, 28. Okay, so you have some time to do that right now. I will give back quizzes and I will hand out the Unit 4 book because you're going to do a little bit of work in there tonight. Okay? Or if you've already seen me, I'll get you one. Let's see, we need that one. Where did it go? Anybody else need a quiz? Yes, you can use a periodic table. Yeah. Page 124 is the very last book page of your book. Okay. Yes, I will print those out. Anyone else want a copy of today's notes? Hands up high. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I'll make 15 because everybody always forgets to tell me. Okay. Yeah. Staple punch. are now up here. Help yourself. Today's notes are now here. Just requested to find you that. So forward. Okay. Like literally, that is it. It is like the easiest one that is doing this grade 9. Yeah, yeah. We're just gonna see some of these in here while we're finishing this unit up because yeah, exactly. Yes. I just need to look at arrow there. I also have people like doing it's not, it's, remember the enrich goes into a different pot. So what happens is that you get your percentage, which is based on everything except for the enrich. And then the enrich goes into a totally different pot. You get a percentage on that. I take that percentage and multiply by 3 because the maximum you can get is 2. Right? So if you got 50% on all the enriched stuff, on average, 1.5. Yes. No. Thank you very much. Let's check and make sure everyone has done the particle quiz. Yes, of course. I'll do this check so I don't. Grace, you still have some quizzes from before. So is there anyone who did not get a copy of the class notes who wanted one? Okay, we're good. Yes. I'll just believe you that you just missed it. It's okay. That was a very weird laugh. Okay. James, periodic table quiz. Did I get to give it back to you? I didn't write down your mark. Silly me. Did you get it back? Andrew, you also need to do the periodic table quiz. Yes. And Catherine. Tomorrow? Okay, good. Yes. Yes. Yes, certainly. Yeah, and if there's anyone who wants to redo average atomic mass, it's available. If you want to. Now, everybody is going to come over here, get a Unit 4 book and a Unit 4 answer key, because you guys are going to be doing 4.1a tonight. We're going to kind of